Okay, so for 5.4, we are going to look at, okay guys, so we are going to be reflecting linear and exponential functions in 5.4. We will reflect linear and exponentials vertically, we will reflect them horizontally, and we will determine the characteristics of those graphs after transformations. We have two key terms, reflection and line of reflection. This is on page 327, so then let's turn to 328. In problem 1, I'm giving you three exponential functions. H of x equals 2 to the x is the basic function. M of x equals negative 2 to the x is your next function, and we determined that we put a negative in front of the result of h of x, right? So whatever you get as the answer in h of x, we put a negative in front of that. And in n of x, that's 2 to the power of negative x. So where did I put the negative in that one? Into the exponent where the x is, which was called the what? Do you guys remember? Starts with an A. Not asymptote. Argument, right? You have your result and your argument. In this case, we made the argument 0. Okay? So number 1, it wants us to write the functions m of x and n of x in terms of the basic function h of x. So this is kind of like what we were doing on that problem that I did in the homework from 5.2, where they want us, or I'm sorry, 5.3, where they wanted us just to write it in terms of the function. So let's look at m of x. M of x is negative 2 to the power of x. 2 to the power of x is the same as which of these functions? H of x. So we're taking the result from h of x, and what did we do to it? We put a negative there. So to write this in terms of h of x would be the same as saying negative h of x. Do you guys agree? Yes. Because 2 to the power of x is the same as h of x, so we can just substitute them in. Okay, do you see what I'm saying? So then let's write n of x in terms of h of x. So what did we do in this case if I wanted to write this in terms of h of x? Did I change the 2 part of the function? No. What part did I actually change? The x. What type of x did I plug in? So this would be h of what? Negative x. Good. So, and we already talked about this, so I'm not going to write anything down. For number 2, it wants us to compare m of x to h of x. So in m of x, we took the answer from h of x, the result, and we multiplied it by negative, right? In n of x, the purple one in mine, what did we do? Did we change the result, or did we change the argument? We changed the argument and multiplied it by what? Negative, right? So we made the argument x the negative. So the argument is what's inside the parentheses, the result is the whole thing, right? So let's look at problem number 4. We're actually going to graph because the graphing calculator helps us with how this is supposed to look. So what I want you guys to do very first is draw your coordinate planes. So with your regular pencil, draw your coordinate planes. And we're probably good with like 5 different lines. So you can make them a little wide. Don't put them super close together. So I'm going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have our coordinate plane. And we're going to graph these on the graphing calculator. So with your regular pencil, we're going to graph 2 to the power of x. So this is how you do it. Okay, so you have your graphing calculator. Turn it on. And so you should see a little blinking, right? Let me turn the light off, see if that helps. Does that help? Or was the light better? Okay. No, there we go. Yeah, better? Let's zoom out. Okay, so you guys can see the whole thing. Well, you can see the little blinking thing, right? So right now I'm on the blank screen. So everybody should be on the blank screen on your graphing calculator. here's what we're going to do. We're first going to graph the basic function, 2 to the power of x. So see up here at the top where it says y equals? Press that, and that's where we're going to put in our function. If you have anything already typed in any of them, highlight up. So let's say I have x plus 3 or plus 2 in there. You're going to go up to that function and you're going to clear it all out, okay? So if you have anything typed in any of them, highlight the function and then clear it out so everything is blank. Okay? You guys okay? Okay, so we're going to be plotting 2 to the power of x. So to do that, we're going to type in 2. And then we want to put the whole thing to a power of x. So to do a power, do you guys see this little arrow pointing up? It's right under the clear button. Oops, I did a 22. 2. You guys see it? This button right here? This is called a caret. This is how we get an exponent. So in math terms, this little caret means an exponent. So you're going to press that. And the way that I always think about it is it's like pointing up, meaning you're raising it to that power. And what power are we raising 2 to? The x, right? So where do we find x? See this green alpha button? Yes? Everybody see the button next to it that says x, t, and there's a little circle with a line through it and an n? That means that's your variable. These are all x, t. This is a Greek letter sigma, and n are the basic variables that we always use. Just press that and it should give you an x. Okay? Oops, I did 2. There should be an erase. There is an, if you ever press more than once, highlight it and there's a delete button. Okay? So if you ever press something that you're not supposed to, instead of having to clear the whole thing, you can highlight what you accidentally pressed and hit delete, and that will take it away. So that's all we're graphing right now. So what you're going to do is see up here where we got to the y in the first place, there's a button that says graph. Press it. And it should graph the whole thing for you. Okay? Mine has little dots on it, so let me go. Error. Okay. So this is what our graph should look like, and this actually should not be a surprise to us because we've graphed 2 to the x before, right? What is, we've graphed this before, so in your book, on your chart, what is always the y-intercept? 0, what? 0, 1. So put a point at 0, 1. See if you guys can look at it, but if I were to plug in 1 to the power of x, so 2 to the power of 1, what would my answer come out to? 2. So you're going to put a point there. And if I were to plug in 2 to the power of 2 is 4, so that's going to be up here. So with your pencil, just sketch the graph. Does it ever touch the x-axis? No. It gets really, really close. And label that h of x. So in your regular colored pencil, you're just doing h of x, which should not be that big of a stretch, right? We've graphed it before. This is where it gets interesting. We are now going to graph m of x. So here's what you guys are going to do. On your graphing calculator, go back to y equals, so hit y equals. Do not erase the one we just did. We're going to graph a second line on the same graph. Okay, so keep that 2 to the power of x. Now what was m of x? Negative 2 to the power of x. So here's what you guys are going to do. Does everybody see the negative symbol? All the way at the bottom. It's in parentheses with a minus. Press that. Now, what do you notice about, in your book, it says negative 2 to the power of x. What do you notice about 2 to the x? It's in parentheses. So do you think we have to put it in parentheses? Yeah. Yes. Parentheses are right up here. It's the first row of black buttons. So do the first parentheses, and then we're going to type in 2 to the power of x. So 2, caret, right? And then remember, your x is this whole list of variables, so you're going to press that. And then close the parentheses. So everybody should look like this. If you're having trouble, ask your neighbor. Okay. Now we're going to graph our first line, 2 to the power of x, and or our first function, and then we're going to graph our second exponent, negative 2 to the power of x. So press graph. Watch what happens. What happened? It flipped which way? Down. Over which axis? The x-axis. So all of our points are the same, except now instead of being positive, they're what? They're negative. So let's graph that line. So using one of your colored pencils. So if my x-intercept was 0, 1, what do you think my y-intercept, what do you think my new y-intercept is going to be? 0, negative 1. When I plugged in 1, I got the point 1, 2. So what do you think this point is going to be? 1, negative 2. And when I got the point 2, positive 4, what do you think my next point is going to be? 2, negative 4. And then, does it ever cross the x-axis? No, but it does get really close on the other side, right? Okay, that is m of x. So make sure you label it. Okay. This is called a horizontal reflection. Okay. So we'll write this down, but this is called a horizontal reflection because it's affecting the y values of our coordinates. Because all the x values were the same, right? It was just the y values that changed. So we're going to graph n of x now. So on your graphing calculator, now we're going to put all 3 of them on the same graph. Okay. So go to y. Keep the first 2, so now we're going to go down to where it says y3. So with n of x, our base was the same, it was 2. And then to the power of, but this time negative x is in what? Parentheses. So open your parentheses. And we're going to type in negative x. So that negative all the way at the bottom, press that guy. Not the minus sign, the negative. And then we're going to press our variable button x and close that parentheses. The reason why we have to put it in parentheses is because that little caret thing only makes the very next number an exponent, unless it's in parentheses. So unless you put the whole thing in parentheses to say that it all goes together, it's only going to take the very next thing as the exponent. Okay, does that make sense? Okay, so now we're going to have 3. So press graph, and let's see what happens. What happened? It's reflected, but which way? Vertical, right, over the y-axis. So remember, this guy is our basic function, and this is the one we just graphed. So what happened? It flipped the other way, right? So let's graph that. So, looking at your graph, does it look like the y-intercept changed at all? No, so your y-intercept is still going to be 0, 1. But all of my x values changed to negative. So where my y value was 2, my x was positive 1. So if I wanted to keep that same y value as 2, what would my x be in that case? Negative 1. So if my y value was positive 4, in the basic it was the x was positive 2, so if I wanted to keep that y value of 4, what x would I plug in? Negative 2. So just the x has changed, right? And then it gets really, 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 really close, but doesn't actually touch. Label that one n of x. And now we have 3 different graphs. Okay, so make sure that you have the 2 different, their basic is in your pencil, the 2 different is in 2 different colors, and each one is labeled, okay? This one was n of x. Okay, so I actually do want to do number 5 and have you guys write it down so that way you have it written somewhere. So look at number 5. You can move the calculators off to the side right now. So look at number 5. It says to compare m of x and n of x to the basic function. So let's do m of x first. What color did mine was? Mine was orange. You can do this in the same colors if you want. So we would say m of x is a reflection. Okay. So I'm going to look at m of x again. So look at m of x. My basic is in black, and my m is in orange. How did I create m? What type of reflection would that be? If I were to fold my paper in half, which axis would I fold? The x or the y? The x, right? Because this one would be if I were to take my paper and fold it over horizontally. So we would say that m of x is a reflection over the x-axis, because the x-axis is the point where I would have folded, okay? So m of x is a reflection over the x-axis. What is the equation for the x-axis? Y equals what? 0, right? At the x-axis, y is 0. So then look at n of x. So going back to my graph, now we're looking at the black and the purple. Which axis would I have folded in order to get the purple one? The y-axis. So we would say that n of x is a reflection over the what? The y-axis. Okay. So n of x is a reflection over the y-axis. And what's the equation for the y-axis? When I'm on the y-axis, x is equal to what? 0. Okay? So make sure you have those written down in words. And then we're going to fill out the table again. Okay. Okay, so here are all of the points for our basic function. And let's look at m of x. We took the result and changed it. So which values were being affected, the x values or the y values? Let's think about it. If I took the result from h of x, 2 to the power of x, and I made the result or the answer negative, does that affect the x's or the y's? The y's, right? So if I had negative 2, in my base function it was 1/4, what would that be in my orange one, m of x? If we made it negative, the answer comes out negative, so what would it be? Negative 1/4, right? That's how we graphed it off of the graphing calculator. So if I plugged in negative 1, in my basic function I got 1/2. If I were reflecting it over the x-axis, that changes my y value to negative 1/2. What about 0? My y-intercept of the basic function was 0, 1, but of the m of x function, my y-intercept was 0, negative 1. So for m of x, when x equals 1, what did my y come out to? Negative 2. And when x is 2, y is? Negative 4. Now let's look at n of x. In n of x, I am affecting the argument. So I'm affecting what I actually plug in. So what's being changed in n of x? Is it the x values or the y values? The x values, because I'm changing the argument, right? So if I wanted to keep my y as 1/4, in my basic function, I had to plug in -2. In order to get 1/4 as an answer in n of x, what would I have to plug in? +2. So I want you guys to finish filling the rest of this out. Okay, so what did you guys get for the next one? +1, 0, -1, and -2. Everybody got that? Yes? So what do you notice? In order to get a reflection over the x-axis, what changed? The x values or the y values? The y's. And did I flip them or did I just change the sign? You just changed the sign. What about to get n of x? When I affected the argument, what happened? Did I flip anything? No, I changed the signs of which ones though? The x's or the y's? The x's, okay? So affecting the argument, what goes inside the parentheses changes the x values. Affecting the result, what's on the outside, changes the y values. So we have a definition. Definition of reflection. Okay, so I want you to highlight these. A reflection of a graph is a mirror image of the graph about a line of reflection. A line of reflection is the line that the graph is reflected about. And then I do want you to write this down because it gives you each one individually. A horizontal line of reflection affects the y-coordinates, and a vertical line of reflection affects the x-coordinates. So horizontal would be like the y-axis, or I'm sorry, the x-axis, and a vertical line would be the y-axis. And then we are going to use this in coordinate notation. So it's the same idea. You can use coordinate notation to indicate a reflection about a horizontal line, meaning that we changed the y values, but the x's stayed the same. And then on the other page, it tells you how to do it for the x values. Okay? So highlight that in your book. Write those two definitions down on your blue page. Okay, guys, so let's get down to number 11. I'm going to give you the basic function and tell you how I want you to reflect it, and then we are going to rewrite the equation. So same idea as what we've done with translations, but now we're doing it with reflections, okay? So we're just reflecting about the horizontal line y equals 0, and then we're going to do the vertical line x equals 0. So it's just about the axes. That's all we're really worried about at this point. So my basic function is a of x equals 5 to the power of x. So the first one, y equals 0, that's what we're reflecting about. We call this a prime of x. That little dash at the top means prime. It's just telling you that we took a of x, the original function, and then we changed it a little bit. So it's like using a different letter, but sometimes we like to use the same letter. That's all it means. So it just means that you took your original a function and we changed it a little bit. So if I am reflecting about the y-axis, is that horizontal or is that vertical? Let's look at it. Remember our axes. Is the y-axis horizontal or vertical? It's vertical, right? So about the line y equals 0, or I'm sorry, y equals 0, that's not the y-axis. Which axis is that? That's the x-axis. So we're doing a horizontal reflection. Does a horizontal reflection, and you can go back to the highlighted part, does a horizontal reflection affect the y's or the x's? What did it say in your highlighted part? The y. It affects the y-coordinates, which is the result, right? The answer? So in order to reflect about the y equals 0, the x-axis, that means that we're changing the answer, the y-coordinates. So this would be -5 to the x. Remember, you take the negative of the whole thing. Okay? So if I wanted to reflect it about the y-axis vertically, what am I changing? Am I changing the result or am I changing the argument? The argument. So that means I'm taking 5, but I'm raising it to the power of -x. Okay? You could also write 5 just to the power of negative x. These are the same. You don't have to put the parentheses around it, okay? Only when you're plugging it in the calculator. But when you're just writing it, you don't have to put it, okay? So here's what I want you guys to do. On the next page, there's B and C. The idea is exactly the same as part A that we just did together. It's just that your basic functions are a little bit different. I'm going to give you like 2 minutes. I want you to try them on your own, and then we'll compare and see what we get, okay? All right, guys, so if I'm reflecting about y equals 0, that's the x-axis. So that affects my y coordinates or the result. Now, in this case, it's already negative. So if I took negative of negative 2x squared, what does that actually make it? Positive 2x squared. How many of you guys got positive 2x squared for that one? Awesome. So what about for reflecting it about the y-axis, x equals 0? That's going to affect what? The argument, so what goes in the x. So it should have been written like this, and in parentheses you just make the x negative, yes? Right? It's just the x that becomes negative. So you just put parentheses around the x and make it negative. Just like when we were adding or subtracting, you put parentheses around the x and then you change it. Now, we could actually do this, right? What's negative x to the power of 2? Negative x times negative x gives me what? X squared. X squared. So this is going to be negative 2x squared. What happened? Did it change? No. Why? Yeah, because we're squaring it, it's going to make the whole thing positive regardless. So if I were to reflect this, do you think my graph would look any different? They'd look exactly the same, right? Does anybody know what kind of graph this is? Is it exponential? It's actually quadratic, which looks like this, right? If I were to reflect that about the y-axis, what happens? It's the same, right? Because they're symmetrical. Okay, that's why that happens. Okay, so let's look at 5 over 4x to the third. If I wanted to change the result, so we're reflecting it about the x-axis horizontally, what would this come out to? What'd you guys get? Negative 5 over 4x to the third. Excellent. Okay. What about reflecting about the y-axis vertically? What would you guys get? 5 over 4 negative x to the third. Now, the third power doesn't always make something positive, right? So we leave it like this. Okay? Questions, comments, or concerns? You guys good? Okay, let's look at linear functions really quick, and then we'll be done. So looking at problem 2, I am giving you the 3 linear functions. Your base function is g of x equals x, so that's really easy. My next function, r of x, is equal to negative x, and s of x is equal to negative x. What do you guys notice about these two things? Are they the same? Whatever I plug in for x, so let's say I plugged in 2 for x, what would I get in r of x? Negative 2. If I plugged in 2 here, what would I get? Also negative 2. So do you think the lines are going to be the same? Yeah, when we graph these, let's rewrite these in terms of the function first. So r of x equals negative x. So what do I do to g of x in order to get that? Negative g of x. So negative's on the outside. And to get s of x, the negative is attached specifically to the x, so it goes on the inside. But let's actually graph them. Okay, so draw your coordinate planes. Remember, this is just a sketch. Probably 5 would do it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's graph g of x first. So let's say I plug in 0 to g of x. What do I get out as an answer? Remember, g of x equals x. So whatever I plug in for x, I also get for y, right? So if I plug in 0 for x, what do I get for y? 0. So plot that point. We're only going to do a few. What if I plug in positive 1? 1. What if I plug in negative 1? Negative 1. What type of function is this? Linear. Label it g of x. Okay. And then let's look at r of x. R of x is negative x. So whatever I plug in for x, I take the negative, right? So if I plug in 0, what do I get? 0. If I plug in positive 1, what do I get? Negative 1. What if I plugged in negative 1, what would I get? Positive 1. Okay, so that's r of x. So graph it and label it r of x. Now, what about s of x? I also take the negative. So if I plug in 0, what do I get? If I plug in positive 1, what do I get? Oh my gosh, it's already on that line. If I plug in negative 1, what would I get? Positive 1. Oh my gosh, it's on the same line. So what do you notice? R of x and s of x are the same. Why? Any ideas? It says r of x and s of x. Negative g of x. It's the same because they're linear. Because if I were to reflect a line, because of the way it's drawn, that's what happens. Okay?